This is a control panel for a high pressure humidification system. You can see that we have a lot of different values here that are going on. Tells you the demand for humidification right now. This is a live panel. It's at 13.2%. JCI, Johnson Controls demand from the building automation system, and a lot of other values here. You can see that we have dollars saved over here. This is how much energy you can save with a high pressure humidification system on a monthly basis. Here are alarms that can send emails, turn on and off, and a few other things. There is a page down where some of the settings of alarms are kept, and values that you can change. Now, before I go too deep into this, I'm going to show you what the system looks like itself. And again, this is a live system. It is PC based, the monitoring. And then here's a picture of the pump of this high pressure humidification system. The control panel is above it, and we'll take a look at some side views here. Here is the pump with this control panel, and then there is the live display that we're looking at. And take a look at it, another side view from the other way. So we'll go back. This is, you can see there's a couple gauges on it, input gauge, output gauge, couple of ball valves, pressure, transducers, transmitters right here, low pressure and high pressure for alarms, water regulating valve, and this is the pump itself. It's a Danfoss pump. The system happens to be have DI water running into it, very clean water, bell housing and motor. And then this is a picture of the ductwork itself that this high pressure humidification system is dispersing its mist humidity into it. You can see that there you have some mist in this area right here and some mist in this area right here. This is just a picture. It's not a live picture. There are 5 different rungs here of nozzles, high pressure misting nozzles. There's one there, 1, 2, can't see it real well, but 3, 4 right up there, and then there's the 5th one. So there are many different stages that you can get out of this, out of all these runs of misting nozzles. And then this is, well, we'll go one more picture here. This is a mixing tank where we actually mix DI water, and this is pure DI water, 18 megohm actually. This is a clean room environment. And this is where we mix it with some city water just to dirty it up just a little. And then this is a sensor probe here, and this is water out. So we'll go back to this last picture. This is the controller that actually opens up this solenoid right here to let a very small amount of water in every time it drops to 3 microsiemens. Right now we're at 4. Drops to 3 microsiemens, and that's when the solenoid opens up and it's throttled to add the water slowly, and only about a cup to about a cup, 8 ounces, half a cup, gets added each time to the 20-gallon tank that's up there. So that's that. So that's how the system looks to a degree. And then back to the live control panel that is monitoring this system right now. Now I am actually in through a remote desktop into this PC that is in the control panel, very small PC that's in there, and it is running Windows 8.1, and this program here was written in Visual Basic that interfaces the PLC that's in the control panel, and and so we're interfacing through Visual Basic into the Allen Bradley Micrologic 1100 PLC. You can see here that we've got stages. You saw those lines, and those misting lines in the picture, and there's actually 4 zones there. And here's the 4 zones, but each zone has a different amount of nozzles. This zone actually has 10 nozzles, this has 20 nozzles, this has 30 nozzles, and this has 40 nozzles. So we stage this differently to give us actually 10 levels of humidification, 10 levels of capacity output. And then actually through varying the speed of the pump, right now we're only at 8 Hertz, we actually can get more levels of humidification out of it, get more capacity levels, and actually this system has around 35 different levels of output, and those 35 different levels keep the humidity within a plus or minus 0.5%, which is pretty good. So this is a somewhat of an introduction. You might be asking yourself, well, how am I doing all this? What's behind this monitoring? Well, I'm going to show you in future videos how a lot of this is happening. One of the last things I will show you here is the Allen Bradley Micrologic ladder diagram, and this is the Allen Bradley controller that actually controls the staging and the alarms that happen within the pump package, the interface into the JCI system. And there's 5 different ladders here. There's a main program, some cycle timers, some solenoids on and off, that's the 4 solenoids, RPM control, that's what gives us more stages, and then some math calculations to give us our energy savings. So that's what makes up the Allen Bradley controller. And this I can turn on and off and make changes remotely, like I am doing right now. And then all the interface program is written by Visual Studios. And you can see here's the program, and this is the development platform, Visual Studios Express Edition 2013. This is the free edition. All this software that I've written this on is free readily available software to do it. So that kind of is enough for the introduction to this. In future videos we'll be going over a little bit more detail of how this whole system is put together, and I guess that should do it for now. Thank you very much for watching this portion of it. Hope to talk to you soon. Bye.